Okay, so until now we have just covered some forecasting techniques which are very basic forecasting techniques, and I also discussed different example that how you will choose a specific forecasting technique, which technique will be the most accurate for a specific data. So we have already covered different common measure of error. Among those we studied cumulative sum of error, mean absolute deviation. So I already solved a simple example in Excel, and I already calculate all these mean absolute deviation, tracking signal, mean square error, and mean absolute percentage error. So now I'm just going to some more advanced model which we using in the forecast when we have some specific variable data exist. So these model are basically called causal model, mean cause, due to some causes, due to some effect, due to some specific injection, due to some impact of a specific variable on another variable. So that is why it's called causal model. These models are also known as external or exogenous model. Exogenous, there are two type of model. One is exogenous and one is endogenous. So exogenous mean which something occur on it from the outside. For example, the demand of a specific product increase. So this demand is from outside, not from inside. So causal model take into account variable in the general economy that affect the revenue obtained by an economy. Okay, so for example, if a person income increase, then definitely that increasement will impact on the consumption of that person. She will spend more money when his income is going up. So that is why these are the causal model, that when some specific changes occur in some specific variable, then the consequences occur in another variable. So causal model take into account variable in the general economy that affect the revenue obtained by a company. So revenue of a company will be affected by some specific external factors. Maybe the demand, if the demand reduce, then the economy, that the revenue of that company will be reduced. If the demand of that product of a specific company increase, then the income of that, the revenue of that company will also be going up. Causal model can be simple or very complex. So in normal situation, when we have two variable, let's suppose one is dependent variable and the other is independent variable. So in this like scenario, the causal model will be very simple, because we can easily check the correlation, we can check the covariance, we can check the behavior of those model, that those both model are going in the same direction or those specific variable are opposite from one another. Most of them require multiple regression analysis, which normally beyond the scope of small business manager. So we will discuss some multiple regression. I will show you how you will run when the number of variable is more than 2, then how you will handle such like scenario. Normally, maybe you will be working on your final year project, maybe you will be working on some specific project, maybe you have different type of data, maybe there are some external variable occur, then what will be the impact on the specific company, revenue, on the economy. So inshallah we will discuss these things. Most of them require multiple regression analysis, which is normally beyond the scope of a small business manager. So after studying this course, after conducting these examples, after studying these concepts, you will be able to do such like multiple regression analysis. You will be able to run these multiple regression analysis. So among those, one of the best known causal model is the regression model. So I will start from a simple regression model example. I will also discuss that example while doing it manually. You can also use Excel, you can also use Minitab, and you can also use R for the analysis, for the data analysis. So when is causal forecasting used? Because we have studied different model, we already discussed trend, we already discussed seasonal type of data, we also discussed the cyclical type of data, and until now we have already discussed the irregular fluctuation, what will be irregular fluctuation. So now the question is, when is causal forecasting used? So you will be able to use these causal forecasting when you know or believe something caused demand to act a certain way. You know that something is happening due to some specific factors. Maybe those factors are related to environment, maybe those factors are related to the economy, maybe those factors related to a specific person income, etc., etc. Demand or sale pattern that vary drastically with planned or unplanned event, that mean why the demand or sale pattern drastically change, why the demand of a specific product is going up. So there will be some exogenous factors. Due to those exogenous factors, it will be going up or it will be going down. Example of a variable that causes demand to act a certain way: sale of ice cream increase when temperature is high. So the sale of ice cream will be going up when the centigrade is going up. So now the sale of ice cream and the centigrade are two type of variable. When one is going up, the other is also going up. When one is going down, the other is also going down. But in some specific scenario, these two variable will not be behaving same. For example, if a person smoking too much cigarette, then the lung efficiency will be going down. So when a person increase the smoking cigarette, then one side, one variable is going up, the number of cigarette will be increased, but on the other side, the lungs efficiency of that person will be decreased. So in this case, it's behaving oppositely. One is going up, the other is going down. Another example is new home start increase when interest rates are low. Okay, so when the interest rate is low, everyone want to buy a home, everyone want to start mortgage. Number of employees increase when demand increase. Okay, number of employees increase when demand increase. So when the demand of a specific product increase, then company hire more people, more employees, because they producing too much, because they want to fulfill the demand inside and outside a specific location. Any plan even could be a sale or an advertisement promotion. So this is also mean causal, that if you spend too much on the advertisement promotion, it will directly impact on the sale. If you not spend on the advertisement, if you not spend on the marketing, maybe your sale will not be going up. Just like if you spend too much money, if you spend too much skill on the advertisement promotion. An unplanned event could be a snowstorm or severe weather, strike or material shortages. For example, the current COVID-19, it's also impact on different production. So I mean, it has some external, exogenous. So we can also use in such like scenario, you can also construct a study, you can also conduct a study to use these causal effect on economy, causal effect on the earning, causal effect on the businesses, etc., etc. So among the causal model, linear regression model is the basic and very simple model, and you people have already studied in the statistic, business statistic, and even also in the business mathematics. Linear, why it is called linear? Linear is a trend line, it is a straight line. If it is non-linear, then non-linear behaving like in the curve, just like parabola, hyperbola, you already studied in the mathematics. So linear will be a straight line. Linear regression use a statistical method known as least square method, LSM. This method minimize the sum of the squared error. So once again, you need to know the deviation. What is deviation? Normally, everyone believe on mean. In your class, when we make your result, we calculate the mean. And you people asking, what is the average of the class? Why you asking? Because everyone believe on the mean. If your marks are too much lower than the mean, then that situation is not good. So we will basically, this model will check the deviation, that how much you deviate from the mean. Mean means the regression line. We will construct a line, then we will check that at a specific duration, how much it deviate from the existing mean. 4 area of variation. So I have already covered these. What are variation in the data? Seasonal variation is caused by the predictable shopping habit of our customer, being depending on the season. When a specific season come, then the sale of a specific, let's suppose fashion, the sale of specific food, the sale of specific vegetable, sale of specific item is going up. So I mean, it's totally depending on season. When season finish, then that is also a short-term trend, it's going down. When the season again, it's going up. So the data behavior in such like variation will be a seasonal type data. Trend variation is already discussed. Trend, it's not a short-term moment in the data, but it's a long-term moment in the data. Trend variation is variation caused by growth or decline in demand for our product or services over time. So trend variation also occur due to some situation in specific economy. For example, when there is a dictatorship in Pakistan, the economy's variation is different when there is some democratic government. So mean trend is a long-term period in the data. Cyclical variation is caused by general economic factor that affect our industry. So mean it depends on the cycle. It depends on the, let's suppose, on the monetary and fiscal policy. For example, if we take the example, some specific policies which specific government planning commission design for a specific country, then those policies, those policies are not for a short term, but it's for a long term period, that it's specifically for a cycle, so it's working in a cycle. Noise is a random variation in our data that is not explained by the preceding factor. So we know nothing about the noise factor. Maybe some random variation, some random fluctuation will be occur, and we will check those random variation, and we will be using different techniques in order to remove that noise factor from the data. So starting from the linear regression model, I have already discussed that we will construct a linear line, a straight line. Linear regression is used to determine two factors: the slope of the regression line, the intercept of the regression line. Basic formula of the regression line: y is equal to a plus bx. So for example, if I construct a xy plane, this is my x and this is my y. Okay, so this will be a trend line. Let's suppose this is now the value of x is this and the value of y is this. Okay, after some time it will be changed like this. Okay, so now basically this thing, these are the variation occurred, this one. Okay, these are the variation occurred in x and in y. So the slope, this is basically the slope of the regression line, the intercept of the regression line, which is basically intercept of the regression line, this line. Basic formula is y is equal to a plus bx, where y is dependent variable. A dependent variable is one that rely on other variable for its value. So in a simple example, in the ice cream data example, what will be dependent variable and what will be the independent variable? So if we consider x will be the time, with the passage of time, when the centigrade going up, the sale of ice cream will be going up. So y is the dependent variable. In this case, the sale of ice cream will be dependent variable. A dependent variable is one that relies on other variable for its value. So mean in this case, sale of ice cream will be depending on the centigrade. Sale of ice cream will be depending on the time period. X is the independent variable. An independent variable is one that does not depend on other variable for its value. So we depend on time not depend on us. Okay, in forecasting model, x is often as a time period. So normally we denote x, and we denote x for the independent variable, and normally dependent variable is time. A is the y-intercept. The y-intercept is the value of y when x equal to 0. So mean as x on this y-axis, x will be equal to 0. Okay, on this, these are 2 points. Now this is the slope, which is a for the y. So a is the y-intercept. The y-intercept is the value of y when x equal to 0. B is the slope of the regression line. Slope is defined as the rise over run. So mean in this example, if you can see, this is the slope. So B is the slope of the regression line. Slope is defined as the rise over run. Least square method. So you need to understand that we will write equation to calculate the regression line by using these two formulas. Y is equal to a plus bx. Basically this y, this is the forecasted. This one is the forecasted one. We want to calculate this value. Y is equal to a plus bx. Just like in the moving average, just like in the exponential, we using the actual sale, we using the actual demand in order to forecast for the next period. So this is basically the new forecasted value. A, which is the intercept of y, and B is the slope. So the formula for B is summation xy minus what is x? X is the independent variable, y is the dependent variable, minus n. N is the number of period which we want to utilize the data. For example, last 4 month data, so n will be 4 in this case. X bar represent mean, and normally mean is, we denote mean with summation x by n, and y bar is the summation y by n. Okay, n is the number of periods, sample size. So summation x square minus nx bar whole square. So in this way we will calculate the slope. When we calculate the slope, then we will be able to use that slope in this equation in order to calculate the trend line. So this equation will give us basically the trend line. The intercept, we can calculate intercept y bar, which is mean, minus b. So we have already calculated this b, into x bar. X bar represent the mean. So before going to that, I just want to discuss a very simple example. For example, we have year yearly data which start from 1999 to 2005, and these are the time period. So we have 7 period, n will be equal to 7. Okay, now this is the time period, this is the electrical power demand. So mean electrical power demand is the dependent variable, and it depend on, why it is dependent variable? Because it depend on the time period. With the passage of time, the electrical power demand increase. Just like in Pakistan, when the population was low, then at that time the demand for the electricity was not too much. But when the population is increased day by day, the electricity demand is also increased, and due to this, the electric shutdown is also occur frequently. So in 1999, let's suppose the electrical power demand was 74, with 2000 it's become 79, and in 2005 it become 122. So now we want to check, we want to forecast, let's suppose for 2006, what will be the forecast for 2006. So if we construct a trend line, that forecast will be most reliable, that forecast will be more accurate. So before going to that, in order to construct the line, what we will do, we will calculate mean, and you people know that what is mean. So mean is equal to x bar is equal to summation x by n. So summation x, what is summation x? Sum of x, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, which is 28, and n is 7. So because we have time period is 7 year data, so 28 divided by 7. So when you divide this with 7, okay, so x bar will be 4. Similarly, you also need to calculate y bar. So we will calculate y bar is equal to summation y by n. So summation y, you need to sum this, the dependent variable data, and you need to divide with 7. So 692 divided by 7, 98.86. Similarly, we need these things in this slope formula. So maybe in the books there will be some different formula, but the result for slope will be same. In the book which I already mentioned to you in your course books, there are 2 books which I already shared with you. In that book, the formula for slope is different. So it's on you now. If you want to use this formula, if you want to use that formula, the result will be same. So summation xy, how we will calculate xy? You need to multiply x into y. So 1 into 74, 74, 2 into 79, 158. Similarly, you will multiply each element of x with each element corresponding element of y. So 1 into 74, 74, 2 into 79, this. So at this way, we will sum, when you sum it, it will be 3063. So 3063 minus n is 7 in our case, x bar is 4, we have already calculated this, and y bar is 98.86 divided by summation x square. So now you need to construct a column, you need to construct x square. So 1 1 square 1, 2 2 4, 3 3 9, 4 4 are 16, 5 5 are 25, and 6 6 are 36, and 7 7 are 49. You need to sum it, which is 140. So we have just put this in this formula, 140 minus 7, once again n is 7, x bar whole square. So now how you will calculate x bar whole square? So x bar is this, when you take the square, 4 for the 16, or you can write this 4 square. When you simplify it, it will be 10.56. When you calculate this, then you already know that a is equal to y bar minus b x bar. Sorry, this is b x bar, this is not b bar, this is b x bar, this is b x bar. So y bar is 98.86 minus 10, b value is 10.54, so 10.54 into, which is x bar value is 4, so is equal to 56.70. So when you construct the slope and the intercept a, then it will be very easy to construct a line, because our trend line equation is y bar is equal to a plus bx. So we have already calculated, this is the value of a and this is the value of p. So when you put these values, a value is 56.70 and b value is 10.54x. So now this is our trend line equation. When we solve this, when we construct, while putting the x value, For example, the x value is 1 in this line, so we will get this. If the x value is 2, we will get this point, this. Okay, so when you construct it, it will be a trend line, and this is your actual demand, electricity demand. So mean there is too much ups and down. If you using this, the original one, maybe the forecast for 2006 will not be good. So we have already constructed this. The forecast for the 2006, you can easily calculate now. The forecast for 2006 will be, I'm just writing this, 2006, and we have already calculated y is equal to, so for 2006 will be, because this is 56.70 plus 10.54, and for 6 it will be 8, because we have 7 period. What will be the forecast for 8 period? 8 period will be 2006. So we need just to write this 8. Okay, and then you need to calculate. So forecast for 2000, I am just writing 2008, 2006 will be, forecast for 2006 will be, so forecast for 2006, which is period 8, will be 141.02. And how we will calculate? Because we have already calculated intercept plus slope of the line, which is 10.54 into the 8 period. So similarly, you can also calculate forecast while using this data for 2007, which will be 9th period. So you need to just put 9 and you will get the forecast for that value. So I am showing you this is for 2006, which is 141. We have already calculated 141. If you sketch this, it will be 141. Similarly for 2007, it will be near to 151 or 152. So this way, when you construct this trend line, you will be able to easily predict, you will be able to easily forecast for the future. What basically we do while constructing this deviation or this linear trend line? Because in the original data, if I show you the original data, this is the original data. When we plot it, it is in scatter form. It is mean there is too much fluctuation. One point is there, one point is there. After in 2001 it is there. Then in 2004 it's going up. Then in 2005 it's going down. So mean the whole environment is a little bit. There is too much variation. It is uncertain. We know nothing that what will be the forecast. So I mean the beauty of this least square example is that it will count your deviation. It will remove the deviation from the data. When the deviation will remove from the data, then you will be on a straight line. And when you going on a straight line, it will be very easy for you to reach to the destination very easily. So basically it removes, this is the deviation 1, this is deviation 2, deviation 3. Basically this trend line remove all these deviation and give you a right picture. So now I am going to show you that how you will use Excel to solve least square method, to use linear regression model, how we will calculate slope, how we will calculate intercept form, and how we will construct a trend line in Excel. So you can see that we have 2-year data starting from January 1, year 1 to December, and then we have another year data which start from January year 2 and finish at December year 2. So we have these two type of variable. One is time period, which start from 1 to 24. There are 24 months in 2 years period. Actual sale, so mean the actual sale in January year 1 is 245 and February it is 244. So the dependent variable represent with the variable y, and independent variable, which is time period, start from 1 to 24 because we have 24-month data. These are the dependent variable actually show the actual sale during these month data. We want to use this data in order to predict for, let's suppose, next year January. So how we will conduct this? So first of all, we want to construct a linear regression equation. How we will formulate that linear regression equation? Then we will construct. So the most important thing, you need to construct you need to check the data behavior, that what kind of data is it. So when you construct it, it will be look like this one. So this is my actual, this is the time period. We want to remove this because the time period already, this start from January to December, then the next year data start from January to December. So this is basically the actual data. So when there is some seasonality in the data, if you can see, it start going up from January, February, March to May, and then it's going down. Similarly, after 3 to 4 months, it's going up, then again it's going down. So there is some seasonality in the data. So which forecasting technique will be the most feasible one? You can also try the moving average, you can also try weighted moving average, you can also try the exponential smoothing average, but the most important thing, you need to check the accuracy. You need to check which specific model, which specific forecasting technique gives you the most accurate result. And how you will check that, you can also understand from the configuration, from the figure. But the most important thing, you need to use different common measure which we already discussed in the previous lecture. You need to use tracking signal, you need to use mean square error, you need to use mean absolute deviation, or you need to use mean absolute percentage deviation. So all those common measure will give you the accuracy of the forecast. So when you check the behavior of the data, then let's suppose I want to construct a linear trend line. But before going to that linear trend line, so you already know that the value of the slope, how you will calculate slope, which is n summation xy minus summation x into summation y n summation x square minus summation x whole square. You can also calculate a while using the other formula which I already mentioned to you, this one, y bar minus b x bar. You can also use this, or you can use this. This is another different formula. In most of the book, they already mentioned this formula for the slope intercept form, which is the intercept of y, this a. So you can also use this. So let me calculate the slope. So how we will calculate the slope? So I'm just going to start that how we will calculate the slope. So this is b. So if I click this, it will show you this formula basically. So let me calculate this for you. 24, which is n, we have 24 month data, into summation xy. So how we will calculate xy? This is xy is equal to x into this is y, dependent multiplied by independent variable. Then you need to drag it down. You need to drag it down. So this is your xy. And this is sum is equal to sum. So you need to select this which you already constructed. So 790277. So in this formula, you can see that E26, this one in the blue one, E26 is the sum of summation xy minus summation x. So what is summation x? How you will calculate this? Is equal to sum, then you need to sum all the values in the time period in the dependent variable into, so you can see B26, this is summation x into summation y, which is C26. So you need to multiply B26 into C26 divided by, now you need to use divided by, you need to make sure that all these parentheses are clear, and if you not place these parentheses, specifically these two and these two in the start, divided by, once again you need to put two parentheses because we want to divide this whole term with this equation. So n, once again, n is 24, we have 24 month data, into D26, so summation x square. How you will calculate x square? So very simple, x is equal to, this is x, you need to take square, okay, 1 1 the 1, 2 to the 4, and at this way you will calculate this. So once again, if I click it, so it is 24 into summation x square. So this is the sum this whole column minus summation x whole square minus summation x whole square. So 300 whole square. So that is why this is B26 whole square. So at this way, when you click this, you will get B value. So this is my slope. Okay. So you can also calculate A. Let me calculate for you A. How you will calculate A? While using this formula. So in order to use this formula, we need to calculate the mean. So how we will calculate mean? Is equal to average. This is my average. Average of what? Average of x. Okay. So enter. This is the average of x is equal to average of y. Normally we denote with the y bar sign. So this is the average of y. So we calculate, basically these are the average. Average is averages, okay, for x and for y. So if I put is equal to, because we want to calculate the a value, if I put a is equal to y bar is equal to y bar is, we have already calculated, which is this one minus b, so the b value is this one, b into x bar, so x bar is this one, enter, you will get 246.8841, 246.9. so this value and this value, these two values are same, so if you want to use this formula, you need for this y bar and x bar value, you need to calculate mean of x and you need to calculate mean of y. Then you already calculated b, which is the slope, so you can easily calculate this. Or if you want to use this formula, the above formula, which is also very simple. In this formula, summation x square, which is 4900, which is d26, into summation y, so we have already calculated, which is c26, so we both multiply this, minus summation x 300, which is b26, into summation xy, so we have already calculated summation xy, which is e26, so e26 divided by n is 24, summation x square is 4900, which represent with the cell number 26, d26, minus summation x 300 square, so 300 square b26, 300 square mean this is b26 cell whole square, so when you enter it, you will calculate the a value. Okay, in this one, this is our trend line basically. So how we will write this trend line? This is very important. Y is equal to, because this is y is equal to a plus bx, so this is a. Now make sure that you put a dollar sign before the variable, because we want to keep this value constant, otherwise this value will be going change, but we don't want to change this value because intercept will not be changed, slope of the line will not be changed, it will be same, plus b, this is the b value. So once again, because we want to keep these values constant, you need to put dollar sign before and after the variable, okay, or you can press F4. If you press F4 button through your keypad, it will automatically consider this value as a constant, so a b value will not be changed, into, now I need to multiply this with the x value, so these are the x time period, because dependent variable depending on the time period, dependent variable depending on the independent variable, so it will be changed with the time period. So let me construct this, because we already construct this, you can see we choose this value a plus b into the x value. So let me drag it down, so the values will be automatically changed while changing the value of x, sorry, it will be, so you can see, let me put the cursor on this, so you can see the a and b value are same, it's not going to change, but the x value change, because dependent variable depending on the independent variable. When the time increase in this ice cream cell, when the centigrade is going up, when the temperature is going up, then the sale of ice cream will also be going up. Okay, if you click on this, you can see a and b value are same, but the x value change. Okay, let me construct this. So select these, sorry, select and, sorry, select this and this, and now you need to construct, you need to check the behavior of this. So if you can see, if I click this, this is the original actual cell. You can see from, this is my actual cell. When I click it, it will show, sorry, this is the actual cell. You can see, and from the figure, if I click this trend line, it shows this trend line which we recently constructed. So for example, if we want to predict for the month, this is 24th month, for the next month, next January of the year, so we can easily construct, we can easily predict, we can easily forecast for the next month while using the previous data. It will automatically calculate the deviation. So this is deviation, this is basically the mean, and these are the deviation. So normally we believe on the mean, we more rely on the mean. So that is why the value of the next period will also be the accurate one as compared to this one, because there is this data is going up and going down, so we will not be able to use this current data for forecasting. But if we construct a trend line, it will be very easy, and it will be very systematic, it will be very accurate. So in this lecture I just show you that how you will use Excel, how you will use, how to construct slope, how to construct the intercept, and how you will construct the linear regression line. But the question is not there, because linear regression will be only helpful when you have only one dependent variable and one independent variable. The situation will become complex when you have more than one variable, when you have two independent variable and one dependent variable, you have three independent variable and you have one dependent variable. So for that purpose we will construct some more multi-regression analysis model. Thank you.